No? Okay. A blank slide, right. Okay. Yeah. This was your question. Floor of 1 minus 2x. Quickly confirm. Are you able to see what I'm writing? Okay. Yeah. Floor of 1 minus 2x. This is what she gave. So to construct a graph, you make a column for x and you make a column for y. Yeah. And then you start with 0 when x is a 0, y is a 1. Yeah. Then you go for a 0.5 when x is a 0.5. Yeah. Then you get y to be a 0. Yeah. When x is a minus 0.5, you get your y to be a 2. Then you take your x to be a 1. Then you get your y to be a minus 1. And take your x to be a minus 1. Then you get your y to be 3. Take your x to be 2. Yeah. Y will be a minus 3. Okay. So let's take this many points as of now and just quickly plot the graph. Yeah. So when x is 0, y is 1. So somewhere here, okay, this is the first point we plotted. Then when it's a 0.5, it is a 0. Yeah, 0.5, it is a 0. When it is a 0.5, it is 0. When it's a minus 0.5, it is a 2. Right. When it is a 1, it is a minus 1. So when x is a 1, we'll put a minus 1 here. Yeah. When x is a 2, it is a minus 3. So somewhere here, another point will come. Yeah. And then further up, when x is, yeah, minus 1, it is a 3. So correspondingly, this is a, gone. Okay. Yeah, now you remember, no, right? You tell me what I have to put here. This is for the x is 0.5. This is our 0.5. Yeah, this is our 1. This is our 1.5. Okay. This is our 2 and so on. So we'll focus on this because we wanted to check at 1. Yeah. At a 0.5, did you say it's a 0? So you said it is a 0. At a 0.5, it is a 0. At 1, what did you say? Minus 1. At 1, what is the value of y? Minus 1. Okay, so somewhere here, we'll plot the point. Yeah. Next. At a 2, it is a minus 3. Right, minus 3. Okay. Now let's go for in-between values. So take a 0.4 and give me what the value would be in the floor of 1 minus 2x. In the floor of 1 minus 2x, take one value before 0.5 and give me the answer. Put a 0.4 and check 0.4 and apply the floor function and give me the answer. In place of x, take a 0.4 and apply the floor function and give me the answer. So would it be this particular? Yeah, it's going all the way like this. Okay, not touching that 0 there. Yeah, something like this. It's a 0.5. So between 0 and 0.5, it is a 0. But at 0, it is a, at 0, what was the value of y? At 0, it is a 1. Between 0 and 0.5, it is a 0. Next, between, at 1, it is a minus 1. Go for a value less than 1. Go for a value less than 1. Put a 0.8 and check and tell me the answer. Apply the floor function and tell me. In place of x, put a 0.8. Okay, so you're saying it's a -1. So something like this, it goes like this, and here it is that empty circle which comes here. Yeah. So you can see that at 1 it is a -1, but between zero point 0.5 and 1, whenever you take and you apply the floor function, your answer was coming to be a -1 only. Next, go for a 1.5. Exactly at 1.5, give me the value of y. Yes, somebody is saying a -2. If you take 1.5, it is a -2. Okay, take a 1.3 and give me the answer and apply the floor function. At 1.3, give me the floor function answer. Yeah, okay, you're confirming it is a -2. So I'm again going like this and trying to put a blank circle here. Right. Okay, this is between. Yeah, this is between 1.5 and 1. What about 1.8? Put a 1.8 and so on. 1.8 and so on. Okay. It is a floor function if you apply -3. So this is how your step function goes. Yeah, now look at this and tell me whether is it continuous? Answer the question, is it continuous? No. Is it differentiable? If something is not continuous, how is it differentiable? No, not continuous, not differentiable. Okay, what is the limit at zero point 0.5? Check whether limit exists at 0.5. Looking at the graph, let me check whether limit exists at the 0.5. No, why is it not? Why is it not the case? Tell me, what is the left hand limit at 0.5? Left hand limit is a 0. Right hand limit is 0 at 0.5. Right hand limit -1. Okay, so one question we have answered in that question paper. She's asking for left hand limit at 0.5. You said it is a 0. Right hand limit is a -1. What about 1? She also asked you about 1. What is the left hand limit at 1 and what is the right hand limit at 1? Left hand limit is a at 1. Left hand limit is -1. Yeah. Right hand limit -2. So both the points, you can see that the left hand limit is not equal to right hand limit. Limit does not exist at 0.5. Limit does not exist at 1. But does limit exist at 0.8? Does limit exist at 0.8? Yes. Does it exist at 1.3? Does the limit exist at 1.3? Yes. Okay. So that's about the question. That's all she gave. If you had if those answers were there, then you would get marks. So everything she's given clearly 10 marks is distributed. One for this definition, one for left hand limit, one for right hand limit. So that scheme I will put up in the Google Classroom. Okay. So that you know how the mark allotment is done. And I don't want to waste any more time on this question. Quickly, let's go to those difficult questions where we combine both Maclaurin's and Leibniz. Anything that is really important which needs to be addressed now, put it here in the chat box. Because I'm not going back to the old questions, I'm just looking at the chat box now, the latest entries. Anything that is worth discussion now at this point of time, or shall we move on to the Maclaurin's and Leibniz? Hurry up. How to do this LHS and RHS in step function. Yeah, with graph only it's easy. It's easy with graph because if you try to do that 1 plus h and 1 minus h answer is it goes wrong. And if you can recall, remember from the Bali, I think we were taking images. We used to find an h tending to 0 plus, h tending to 0 minus. Do you recall? Can you remember? And then we were mentioning h tending to 0 plus and 0 minus. Then we decided to just go for h tending to 0. So h tending to 0 works fine for most of the questions. But when it comes to questions on seed and floor function, h tending to 0 will not work. Again, is h tending to 0 from left hand side? Is h tending to 0 from right hand side? You have to check. So that is why that particular way of evaluating limits will not work here. It won't work here. Yeah. So when it's a floor and ceiling function, go for one value smaller, one value bigger, and try to check whether you're getting the same answer. Okay, so if somebody is asking you to evaluate a limit at 1, go for 0.9 and then go for 1.1, and you can clearly see your answer is not matching. So you can conclude that left hand limit not equal to right hand limit. No need. No need. See, look at my graph, how bad it is. Yeah, no need. Just have a graph and show us the curves. That's it. No marks for drawing it neatly. Okay, so I'm going back to those questions. Just give me a minute's time. Yeah, sorry for the delay. Confirm whether you're able to see a slide. Are you able to see the slide? Right. Okay. Yeah. So I just wrote the important steps here. The in between I missed a few because yeah, while explaining, you can fill in those gaps. Okay, what is required? Minimum information I have put up there. Okay, so first thing we'll try to discuss is this is our function. It is a sine of m sine inverse x, sine within brackets m sine inverse x. We want to find the Maclaurin series for this function. Y is equal to sine of within brackets m sine inverse x. So first thing we know, I'll have to define the derivatives, at least a few derivatives, and then I have to evaluate them at 0 because this is a question on Maclaurin series. So first thing we do is what is y of 0? We'll evaluate, keep it ready for us. So wherever x is there, if you put a 0, quickly confirm whether y of 0 is a 0. Wherever x is there, if you put a 0, would you get this? Sine inverse 0 is 0, sine 0 is 0. So do you get a y of 0 to be 0? Yes. Okay, next we differentiate this one. Sine of function derivative is a cos of that function, and derivative of that function m sine inverse is x is m upon square root of under root 1 minus x square. So have I differentiated it right? Quickly check. Derivative of sine is a cos function, and within brackets whatever is there, the derivative is m sine inverse x, derivative is m upon square root of 1 minus x square. Now wherever x is there, put a 0 and check. Cos 0 is a 1, m upon square root of 1. So do you get an m? So is the derivative of first derivative of y at 0 an m? Any repeat? First derivative of y at 0 is an m. Any repeat? No. Okay, so it's clear. Then what have we done? We cross multiplied. We took the square root of 1 minus x square there, y1, and then m comes ahead, a constant term. We have a cos function there. Throughout, you square it. Your square root of 1 minus x square will just become a 1 minus x square, a y1 square. Okay, when because you're squaring throughout, and m square will come, and cos square, can I write it as a 1 minus sine square? And 1 minus sine square is nothing but 1 minus y square because sine is y. Quickly check whether this step is right or is it a repeat for anybody. Mention a repeat if you haven't got it. Yeah, what we're doing here is we cross multiplying the square root of 1 minus x square to that side. So once you cross multiply, this is the equation that you got. Once you square it, check whether you will get this one. Square of under root 1 minus x square is a 1 minus x square. Square of y1 is a y1 square. Square of m is an m square. Square of cos is a cos square. Cos square is nothing but 1 minus sine square. And what is sine? Sine is our given question. Y. Sine function of this is a given question y. So 1 minus sine square, can I write it as a 1 minus y square? So have I got an equation which involves the first derivative of y1 and the given function y? If you still not got it, please mention a repeat. I'm just using a trigonometric identity. Cos square is equal to 1 minus sine square. And in place of sine square, I'm using the given question because given question y is a sine function. Okay, no repeats. I'm assuming you understood. If it is a repeat, 30 seconds, please mention a repeat. Okay. First thing what we're doing is, Hitesh, we cross multiplied Hitesh, then we just squaring throughout. Write it as it is, square throughout and write. I am missing two steps there in between. Okay, but those two steps are not important if you know how this step will come. So left hand side is okay, no? When you square under root of something, you will get without the under root. Y1, when you square, you get a y1 square. M on the right hand side, square is an m square. But what about this cos function? Cos of some function. Square is cos square. Then cos square you can always write as 1 minus sine square. But in place of sine, can I bring in my question? Because my question sine is the y. Y is equal to sine of some function. So sine square is there, y square will come. So just for convenience sake, now do we have an equation which involves y and its derivative? Y and its derivative. Now differentiate this throughout because now we already got our value of y at 0. We already got our y1, the value of y1 at 0. Next, we want to get the value of y2 at 0. So to get that, you differentiate throughout. So 1 minus x square into y1 square, if I use product rule, will I get these two terms? Quickly confirm left hand side. 1 minus x square as it is. Derivative of y1 square is a 2 into y1 into y2 plus y1 square as it is. The derivative of 1 minus x square is a minus 2x. Left hand side is right, Hitesh? LHS is right if I apply the product rule. Right. Look at the right hand side. M square is a constant. What is the derivative of 1 minus y square? Derivative of 1 is a 0. Derivative of y square is a 2y y1. So we have a negative sign and an m square. So quickly check and confirm whether this equation is right. Yeah. If this equation is right, which is the factor I can cancel throughout? What is common in all the three terms that I can cancel throughout? Which is the term which I can cancel throughout? 2y1. Excellent. Yeah, cancel your 2y1 throughout. Would you be left with this equation? If you are left with this equation, try putting x equal to 0 and see what is the value of y2 at 0. What is the value of y2 at 0? Is it a 0? If it is 0, say yes, otherwise mention a repeat. Wherever x is there, put a 0 and check whether y2 of 0 is a 0. You have to use the earlier values. You might have to use the y of 0 value. Anybody who's not understood how to get a y2 of 0, mention a repeat. If you got it, then mention correct. Yeah, some of you are confirming that y2 of 0 is a 0. Okay, you had to use the y of 0 there. Then only you will get a 0. So you have to, whatever is done, block them like this, put them in boxes there so that you also remember what the values are. And then you will need them. Okay, 30 seconds. Any repeat for this step? Then I'm applying Leibniz from here. Okay, so no repeat. Why don't we go on to Y3, Y4, and so on? Yeah, because as you differentiate, how many more terms will you get, Rishikesh? It's going to involve a lot of terms. So that is why Leibniz is convenient for us. Leibniz gives us a recurrence formula. Okay, it straight away will give us a recurrence formula. In fact, look at this formula which we have. This is coming only because of Leibniz. So if you have this formula, then I can quickly list out Y3, Y4, Y5, and so on. Because some terms are zeros. When you see those terms are zeros, imagine in your Maclaurin series also some terms will not be there. So that is why we have to go till Y5, Y6, and so on. Because alternately zeros are coming. Yeah, so that is why we are using Leibniz theorem. We are using Leibniz only for having the convenience of having a recurrence formula so that I get y3 from, yeah, I get y3 from y1, I get y4 from y2, I get y5 from y3, and so on. So you're getting a recurrence formula which involves yn plus 2 with yn. Now, how to apply Leibniz? Look at the first term. Leibniz theorem is for product of two functions. First function 1 minus x square as it is. Nth derivative of y2, it is a yn plus 2. Please look at this one. I'm looking at this line when I'm talking. Yeah, we are applying Leibniz on this equation. So first function 1 minus x square as it is. Nth derivative of y2 is a yn plus 2. Then second one is an NC1, so I put an N there, and derivative of 1 minus x square is a minus 2x, and then we have the yn plus 1, because yn plus 2 is now a yn plus 1, and then NC1, so n into n minus 1 by 2, minus 2x, derivative is a minus 2, so a minus 2 is as it is, yn plus 1 further reduced to yn. Would the next step come? Would the next step come? Because 1 minus x square, first term, minus 2x, second term, minus 2, third term. After that, derivatives will be zeros. After that, the derivatives will be zeros. Shouldn't the sign be plus for the second term? How? 1 minus x square, what is the derivative, Rishikesh? 1 minus x square, what is the derivative? Yeah, minus 2x. So that is why a negative sign. Minus 2x, what is the derivative? Minus 2. That is why another negative sign in the next step. Yeah, so we got three terms for the first term. Now start applying Leibniz for minus x y1. So minus x as it is, y1 nth derivative is a yn plus 1. Then n will come, minus x derivative is a minus 1. yn plus 1 reduced to yn. So do I get just two steps? The next one would be a 0 because first function is a minus x, derivative minus 1. After that, derivatives are 0. So quickly confirm to me whether we got our left-hand side right, because right-hand side is straight away the nth derivative of minus m square y, which is a minus m square yn. Yeah, if you reach till here and you got it, simplify and check whether you're getting the next equation. But if you haven't got this equation, mention a repeat. Okay, but you will mention a repeat after 30 seconds. You do that to yourself, then only you can mention a repeat. We are using Leibniz only for the convenience of getting a recurrence formula. In the last term of LHS, okay, last term of LHS, yeah. How did n come? NC0, NC1. Don't forget those coefficients in Leibniz neon. You have NC0, NC1, NC2 coming with as coefficients for each term. Yeah, so that is why an n will come for the second term. If you had a third term, n into n minus 1 by 2 will come. If you had a fourth term, n into n minus 1 into n minus 2 by 3 factorial would have come. Yeah. This is what will happen in the exam also. So many of them will forget these coefficients and then they're ending up with wrong equations and wrong answers. Be very mindful of those coefficients. Shouldn't it be x yn plus 1 minus yn? Where is it? Okay, so Harsimran is saying there is some problem with this term. Let's quickly check while taking common out. Yeah, xy1, if you take common out, xyn plus 1, from the first term you get a minus 2n and then, yeah, minus 1. Yes, yeah, yes, yes. Minus n is there, yeah, and a minus 1 is there. Okay. Oh, or let's just make this a minus. Okay, so let's just make this a minus and this a plus. Now is it okay, Simran? Quickly check. Thank you. Yeah. What about the m square minus n square? Yeah, you have to apply y of 0 to get y2 of 0. Yes, Mark. You have to apply y of 0 to get y2 of 0. Yeah, because you're evaluating terms. Yeah. Anything else? 30 more seconds. It's not n square. Where is it? M square minus n square. Yeah, last term. Okay. Last term, 2 and 2 got cancelled. It's a minus n square and then it's a plus n. That plus n got cancelled with this minus n. Yeah. And then we have a minus n square and m square when it comes from that side, it comes as a plus m square. Yeah. M square minus n square seems to be right. Simran, check again. Because only a plus n and a minus n got cancelled. Right, right. Finished? Anybody still here? From here, is it a move on? I am here and I am asking you, is it a move on from here or any explanation? For every even derivative, the value of the function is becoming 0. Yeah, maybe, yes. Y of 0 will be 0, y2 of 0 will be 0. Yeah, y4 will be 0. Yes. Yeah, it's almost same like the previous question except n square minus m square, Jason says. Yeah. Right. Okay, I don't see any one of you in this. I'm moving ahead. So once you applied Leibniz, wherever x is there, put a zero. What happens to your first term? Would it become a yn plus 2 of 0? Yeah. So when x is equal to 0, you can see that it is a yn plus 2 of 0. Second term completely would it vanish because it's x into something? Second term, would it be completely 0? And look at the third term. Third term is m square minus n square. When I take it to the right hand side, would it become an n square minus m square? And then we have a yn of 0. So this is our recurrence formula. This is about the value of the derivatives at 0. Because wherever x is there, we put a 0 and we got this equation. Is it correct or is it a repeat for this recurrence formula? This recurrence formula we're getting for x equal to 0. Is it correct or is it a repeat? Repeat. Okay. Hitesh, did you get this equation right? This one, did you get it right? Or this one also I need to explain? Hitesh, this is okay? This equation? Yeah, right. In this equation, wherever x is there, put a 0. What happens to the first term? 1 minus x square becomes a 1 minus 0, which is a 1. And yn plus 2, when x is 0, is yn plus 2 of 0. That means yn plus 2 at 0. So that you have to put there. Yn plus 2 of 0. Next term has an x there. So the moment x becomes 0, next term is completely not there. And then you look at the right hand side. Yeah, m square minus n square yn is there. So if in wherever x is there, if you put a 0, m square minus n square is a constant that will remain as it is, but yn will become a yn of 0 because you're doing all this at x equal to 0. So you will get a yn of 0. Got it, Hitesh? Second term only has vanished because it has an x outside. It should be minus. Oh, but it should be, what is it? Minus, where is a minus coming? Before applying Leibniz. Yeah, I'll explain. When we transpose, yeah, that minus I took care of it inside. I sent the minus inside. So m square minus n square on the left hand side became an n square minus m square on the right hand side, English. We just changed their position. Yeah. You can keep it as it is. You keep the minus sign as it is. Yeah, you can keep the minus sign as it is. No problem. Yeah, right. Okay, so this much. Yeah. So now we have this recurrence formula and then we proceed. Okay, so this is our recurrence formula that we have. From this recurrence formula, quickly find your y3 of 0. That means in place of n, what are you putting? Hitesh, in place of n, what will you put if you want your y3 of 0? Look at this recurrence formula. In place of n, what will you put to get your y3? 1. Okay, so y3 of 0 is in place of n, you put a 1, so 1 minus m square. And what is a y1 of 0? Look into those boxes that you've already highlighted. Y1 of 0, that's an m. So, okay, so y3 of 0 is confirmed. Y4 of 0, yeah, yn plus 2 means in place of n, you will get a 2. So yn plus 2, in place of n, you will get a 2. So y4 coming in terms of y2, y3 coming in terms of y1, y5 coming in terms of y3. So if you do the substitutions, quickly confirm whether these are right. I only mentioned till y5 and I stop there. Is y5 right? Quickly check for yourself and mention a correct if you finished. No, this question is not about nth derivative. This question was about getting our Maclaurin series. Yeah, so read the question carefully in the exam also. See what the question is about. It's the Maclaurin series that we want. So this is the formula for Maclaurin series that you wrote in yesterday's class. Fn of 0 x power n by n factorial. And then wherever n is there, first you put your summation goes from 0 to infinity. So when n is a 0, you get just an f of 0. When n is 1, f dash of 0, f double dash of 0, f triple dash of 0, and so on, dot, dot, dot. And then substitute the values and tell me whether this answer is right. Okay, take 2 minutes time, finish it off. At least three terms need to be mentioned on your Maclaurin series. Nobody will just mention one term or two terms. At least minimum of three terms should be there on the right hand side. If question specifically says first find four terms, yeah, there are questions where they mention find the first four terms, then you have to go for four terms. Otherwise, at least three terms. Yeah, if you didn't have the recurrence, that means one equation you're differentiating it five times and you would be having n number of terms in that, so many terms. So for convenience, we use Leibniz theorem. Question will never mention that use Leibniz theorem to do this. Okay, we are using it because using Leibniz, it's convenient to get a recurrence formula. Question will never mention that. You will have to remember. If you are very patient, go ahead and differentiate again and again and get some fifth derivative, sixth derivative, seventh derivative. Go ahead and finish it off if you can handle that differentiation. Otherwise, convenience, use Leibniz. Now that's why, Atharva, what I'm trying to say is it's not mandatory to use Leibniz for Maclaurin's. Question will be Maclaurin's. We are using Leibniz to get the derivatives. Yeah. Simran has confirmed that the final answer is right. No typos anywhere. Yeah, only one typo was there that you have to remember. This we made a minus and this we made a plus. Yeah, that was the only typing mistake she said. Yeah. Yes, dot, dot, dot. Finished, move on. What is it? Doing it. I'll share these with you. I'll put them up in the classroom. Shall we do the next question? What is it? Is it a doing it? Move on. Why are the even terms zero? Because when you evaluated, you were getting zero, right? Y of zero was zero. Yeah. All those derivatives, you were getting them to be zeros. You got your y of 0 to be 0, y2 of 0 to be 0, y4 of 0. Yes, yes, you can leave. Yeah, I'm not saying that everybody, so specifically somebody, I'm saying you can leave. Yes, Nachiket. Yeah. Some terms became zero, so that's why I put them zeros. When you write the final answer, you will skip those zeros and just write the first three terms, non-zero terms. Yeah. Explain the part before applying Leibniz. Before applying Leibniz. Anybody doing it on this slide? Can I move back, move ahead? Mark, do you have the 11 o'clock class? From 11, do you have a class? No class at 11. So, Mark, what I'll do is I'll finish off with the next question and then come back to this one. Mark, probably when I do the next one, this also might get clear for you. Is it okay? Yeah. Okay, so I'm assuming you're finished. I'm moving on to the other one. Yeah, next question is about a tan inverse x. Quickly, wherever x is there, if you put a 0, do you get y of 0 to be 0? Confirm. Is y of 0 0? Tan inverse 0 is 0. Yeah, they usually come as 8 markers in the offline exam. So now in the online exam, they might just become a 5 marker. They might become 5 markers or they might become 10 markers in the online mode. Offline, it was 8 marks. Yeah. Yeah, okay. Y is equal to tan inverse x, so y of 0 is 0. Next, differentiate tan inverse x 1 upon 1 plus x square. Now, wherever x is there, you put a 0, y1 of 0 is a 1. Confirmed. Cross multiply, take the 1 plus x square that side, 1 plus x square into y1 equal to 1. Now differentiate product rule, 1 plus x square into derivative y2 plus derivative of 1 plus x square, which is a 2x, 2x into y1 equal to 0. So now wherever x is there, you put a 0 and confirm to me whether y2 of 0 is right. If you have reached till here, let me know. Yeah, once you reach here, please confirm so that I also know you finished that much. Any doubt till here? Okay, so many of you are confirming that this is right. I'm assuming you finished it here. Yeah, so you got y of 0, you got y1 of 0, you got y2 of 0, second derivative also is coming to be 0. So you are able to see a pattern coming there. So all the even derivatives are becoming zeros. So now we want a recurrence formula to find at least first 3 terms. We want to find the first 3 non-zero terms. So for that, I'm applying Leibniz on this step. So Mark, look at this carefully. We're applying Leibniz on this step. So first function 1 plus x square as it is. Nth derivative of y2 is yn plus 2 plus nc1 is an n and derivative of 1 plus x square is a 2x and yn plus 2 reduced to yn plus 1. Next, n into n minus 1 by 2 because we're looking for nc2 now and derivative of 2x is a 2 and yn plus 1 further reduced to yn. Would I get any more terms there, Mark? 1 plus x square, first term. Derivative 2x, second term. Derivative 2, third term. After that, derivatives are 0. So, for this particular term, you will not get any more steps using Leibniz. Start with the next term, 2x y1. Yeah, 2x y1, we want to apply Leibniz. So keep the 2x as it is. Nth derivative of yn is a yn plus 1. So we got this term 2x as it is. And nth derivative of y1 is a yn plus 1. Next, nc1, so n should come there. And derivative of 2x is a 2, which I put there. So 2 is there, nc1 is there yn plus 1 further reduced to yn. Okay, next terms, will they come? Because your function was a 2x, 2x as it is, derivative 2, next derivative would have been a next derivative would have been a 0. Yeah, so that is why no more terms. So this is how you apply Leibniz. Now what you do is just take common out. I have just yn plus 2 term, only one term that came as it is. But yn plus 1, I can see there are 2 terms there. A 2x is common, so you took a 2x common out. An n here, a 1 there. So is it a 1 plus n within brackets? Mark? A 1 plus n within brackets? For the yn plus 1 term, yeah. Okay, and then start with your yn term. An n square is there, a minus n is there, a plus 2n is there. So is it an n square plus n? Quickly check the common out and tell me whether this step is right. Then we move ahead. If you've reached till that step, then start examining the recurrence formula. Put an x equal to 0 and confirm to me whether this recurrence formula is right. If it is right, find at least 3 derivatives. I can be wrong while I was solving. I could have made a mistake. So check carefully if these values are right. If there is any repeat for anything till here, let me know. After that is just applying in the formula in the Maclaurin series. If there's any repeat for anything till here, let me know. Otherwise, it is just going and straight away substituting in the formula, the Maclaurin series formula. Check the answer, check the final answer and tell me whether it's right. Do we have our first 3 non-zero terms as x minus x cubed by 3 plus x power 5 by 5 and so on. So you can see the Maclaurin series of tan inverse x is this. What if we keep the denominator in factorials only? Yeah, go ahead. Keep it as it is. No problem. Only because we were getting numbers on the numerator also, we cancelled out and we got rid of the factorial. Only because our derivatives were, yeah, our derivatives were coming as -2, 24 and so on. We simplified and then we wrote as it is. What do you think the next non-zero term would have been had we mentioned that also? Right now an x is there, minus x cubed by 3 plus x power 5 by 5. Next non-zero term would have been a y. Yeah, right. No, no, in the series, I'm asking you in the series, what would have been the next non-zero term? I'm asking the Maclaurin series. If we went for one more term in the Maclaurin series, we would have got what is our next non-zero term? Zero, non-zero term. Non-zero. Yeah, minus x power 7 by 7. Yes, minus x power 7 by 7. Right. Okay. So I hope it is clear. Yeah, this is another two questions I have mentioned here for you to try for yourself. Okay, the first one is an e power a sine inverse x, e power a sine inverse x, and the next one is log of x plus square root of 1 plus x square. Use the same approach, solve these questions, and you are able to get the right hand side expression. Please share with your classmates. Just put up the image in the class group so that the others also can solve and check for themselves. Okay. So whoever is completing these two questions, as soon as you complete, take an image and put it up in the class group. And if you could send me also, it would be helpful. Okay. So check whether you're able to get the right hand side answers. Answers are given here. Final answer. Nothing, no doubts. You can leave right away. All the best to all of you for your midterm